Before we plunge into the announcement, it's critical to comprehend the significance of what we are examining. The Large Hadron Collider, LHC, overseen by CERN, represents a stupendous leap forward in the area of science. Extending across 17 miles, this complex organization of superconducting magnets is not only the largest but also the most powerful atom smasher ever constructed. It stands as a testament to human creativity and the remarkable accomplishments we've made in the domain of scientific understanding. Surprisingly, the LHC is powerful enough to recreate conditions similar to those that existed at the beginning of the universe. Yet, as we venture into the vast territory of the cosmos, we must ask, could this machine, which seeks to uncover the deepest mysteries of existence, also expose us to unforeseen dangers? Founded in 1954, CERN is one of the most respected scientific research organizations in the world. With 23 member countries and a vast network of scientists, it serves as a central hub for collaboration and groundbreaking discoveries. While the LHC is its flagship project, it is only one piece of a broader array of particle accelerators and experiments. Think of it as a track, not for cars or horses, but for subatomic particles racing against one another in a high-stakes test of speed, precision, and the fundamental nature of reality. Inside the LHC, protons are accelerated to speeds approaching that of light, simulating the energy levels present at the moment of the Big Bang. The resulting collisions generate temperatures far exceeding those in the Sun's core. A series of magnets guide the protons on their paths, while sophisticated cooling systems keep the magnets at temperatures lower than those in outer space. These collisions are deliberately set to occur at 4 separate locations around the accelerator, where specialized detectors, ATLAS, CMS, ALICE, and LHCb, record data. Each detector plays a unique role, offering distinct perspectives on the aftermath of these high-energy collisions. Together, they function as enormous cameras, capturing the results for researchers to analyze. Scientists carefully sift through the debris to identify elusive particles, such as the Higgs boson, often called the God particle, and phenomena that could shed light on the universe's building blocks. By focusing on the subatomic, researchers hope to gain insight into the very fabric of the cosmos. However, every discovery made at the LHC raises even more questions. The LHC is more than just a scientific instrument. It symbolizes humanity's enduring curiosity and quest for knowledge. It reflects our drive to understand the forces that govern our reality. Yet, as we push the boundaries of the unknown, we must also confront the ethical and existential dilemmas that come with it. What risks could emerge from probing too deeply into the unknown? Could our quest for knowledge unleash forces beyond our control? At CERN, where the limits of human understanding are pushed to their extremes, a startling realization has emerged, one that has sent shivers down the spines of even the most seasoned scientists. Brian Cox, a former CERN researcher and a well-respected figure in particle physics, recently made a disturbing statement that has both intrigued and unsettled people worldwide. Cox revealed that the LHC's purpose is to simulate a miniature Big Bang, a small-scale version of the very event that created our universe. Cox elaborated on the immense potential of the LHC to uncover groundbreaking discoveries, such as unraveling the mysteries surrounding dark matter, a substance that constitutes a significant portion of the universe. The possibility of harnessing the fundamental forces of the universe is undeniably captivating, but it also comes with its own set of risks. The miniature Big Bang is not just a theoretical concept, it is a real phenomenon occurring within the LHC. The collider recreates conditions of intense heat, pressure, and energy, mirroring the very environment at the dawn of the universe. It is as though we are witnessing the birth of time itself. However, with such immense power comes great responsibility. What if something goes wrong? This concern is not new. In 1978, Russian physicist Anatoly Bugorsky experienced an incident that profoundly altered his life. While working with the U-70 synchrotron at the Institute for High Energy Physics in Russia, a malfunction caused a proton beam to accidentally cross his path. The beam, traveling at an unimaginable speed, pierced his skull, entering from the back and exiting through his nose. Although Bugorsky was struck by a flash of light brighter than 1,000 suns, he remained conscious and sought medical attention. The outcome was both fascinating and alarming. He lost hearing in one ear and experienced partial facial paralysis. Despite the severity of the injury, his cognitive abilities remained intact, and he continued his scientific work. Bugorsky's experience serves as a grim reminder of the power and potential dangers of particle accelerators. The risks associated with an atom smasher like the LHC should never be underestimated. Concerns about unforeseen reactions that could alter the very fabric of reality have led some scientists to worry about the possibility of creating a miniature black hole inside the collider. Black holes are regions of space where gravity is so intense that not even light can escape. These formidable forces lurk at the edges of the universe, and the idea that the LHC could create even a tiny black hole is both awe-inspiring and terrifying. Could such a black hole grow uncontrollably, eventually consuming the Earth from the inside out? CERN experts have reassured the public that any black hole created would be highly unstable and would dissipate almost instantly. Still, the remote possibility of such an event has sparked widespread debate and concern. To understand how the LHC could potentially create a black hole, we must first examine the basic operations of a particle accelerator. When protons collide at nearly the speed of light, the energy released is so immense that it can distort the very fabric of spacetime itself. Imagine a trampoline stretched tightly, with a heavy object dropped onto it. The fabric bends, and if the object is massive enough, it can create a depression so deep that anything nearby would be drawn into it. This analogy offers a glimpse into how the LHC might affect spacetime at a quantum level, where the laws of physics become strange and unpredictable. A theory has been proposed suggesting the existence of extra dimensions beyond our familiar 3 dimensions of space and 1 of time. If these extra dimensions exist, the LHC could potentially tap into them, possibly creating a gravitational well that forms a miniature black hole. The possibility of this happening has attracted the attention of renowned physicists, including the late Stephen Hawking. In his writings, Hawking warned about the Higgs boson becoming unstable at extreme energies, potentially triggering catastrophic consequences such as vacuum decay. Sir Martin Rees, a distinguished astrophysicist, also raised concerns about the LHC's experiments. In his book on the future, Prospects for Humanity, he explored the potential dangers posed by particle accelerators, acknowledging that while the chances of such an event were low, even a small probability warranted careful consideration. The stakes are immense, and the margin for error is razor-thin. Researchers at CERN have conducted extensive simulations and analyses, taking precautions to ensure the safety of their experiments. Brian Cox himself has acknowledged the concerns surrounding the LHC, emphasizing that strict safety measures are in place. These safeguards include thorough reviews and protocols to ensure that the collider's operations are carried out with the highest level of care. According to Cox, the energy levels involved in LHC experiments are far lower than those that naturally occur on Earth. Even if a black hole were to form, it would be so small and unstable that it would dissipate almost immediately, releasing a burst of energy as predicted by Hawking's theory of Hawking radiation. Some have speculated that the LHC's experiments could open a doorway to another universe or dimension. While mainstream scientists generally dismiss this idea, it has captured the public's imagination, fueling myths and rumors. What lies beyond our universe? Could we accidentally unleash forces or entities that we don't fully understand? The concept of parallel dimensions is not new. String theory, a leading candidate for a unified theory of everything, suggests the existence of more than the 4 dimensions we experience, 3 of space and 1 of time. These extra dimensions may be hidden from our senses, but under extreme conditions, they could theoretically be accessed. Imagine the LHC as a key, unlocking pathways to realms that have been concealed since the dawn of time. When protons collide at energies never before achieved on Earth, they could create ripples or waves that probe these hidden dimensions. While this remains speculative, it illustrates the allure of the unknown. The possibility of discovering other dimensions continues to captivate the public, even though mainstream scientists remain skeptical that the LHC will open a portal to another universe, or to something darker. Nonetheless, the idea of the LHC as a cosmic key unlocking new realities continues to fascinate many. So, should we be worried about the risks involved with the LHC? It's easy to get caught up in sensational headlines and fears of cosmic catastrophes. The reality, however, is that scientists at CERN are acutely aware of the potential risks. They have taken every precaution to ensure the safety of their experiments and continuously monitor and evaluate their work with the highest level of diligence. The potential benefits of their research, such as uncovering the secrets of dark matter, discovering new particles, and expanding our understanding of the universe, are truly extraordinary. These breakthroughs represent a giant leap forward for science and humanity, offering insights that could reshape our understanding of existence itself. In the end, The Large Hadron Collider is not just a machine, it is a symbol of human curiosity, ingenuity, and determination. It represents our relentless pursuit of knowledge and our desire to unravel the mysteries of the cosmos. While the unknown may be daunting, it is also what drives us to explore, to question, and to discover. And as we continue to push the boundaries of science, we do so with the hope of unlocking the secrets of the universe, and perhaps even finding our place within it. Yet, as we push the frontiers of human knowledge, we must tread carefully, balancing our thirst for discovery with a responsibility to minimize risks. The Large Hadron Collider is a double-edged sword, a tool of unparalleled scientific potential and a reminder of the thin line between progress and peril. While CERN's assurances and rigorous safety protocols provide comfort, the lingering what-ifs remind us of the complexities of exploring the unknown. As humanity ventures deeper into understanding the universe's most fundamental truths, it is essential to consider not only the scientific implications but also the ethical and philosophical questions raised by these pursuits. What responsibilities do we hold as custodians of such powerful technology? Should there be limits to what we explore, or is the pursuit of knowledge inherently boundless? These questions do not have simple answers. They echo through the halls of scientific institutions, debate forums, and even popular culture. The fears and hopes surrounding the LHC highlight the inherent tension between curiosity and caution, ambition and accountability. Every groundbreaking experiment carries with it the dual possibility of remarkable discovery and unforeseen consequences. In the case of the LHC, its successes are already monumental. The discovery of the Higgs boson in 2012, for example, was a watershed moment in physics, confirming a critical part of the Standard Model and earning François Englert and Peter Higgs the Nobel Prize in Physics in 2013. This particle, often called the God particle, helps explain why particles have mass, a cornerstone of modern physics. But the work of the LHC is far from over. Researchers continue to delve into mysteries like dark matter and dark energy, phenomena that together comprise approximately 95% of the universe but remain largely unexplained. Beyond this, the LHC aims to investigate the asymmetry between matter and antimatter, the force of gravity at the quantum level, and even the possibility of entirely new physics beyond the Standard Model. These objectives carry with them the promise of revolutionary discoveries, answers to some of the most profound questions humanity has ever asked. What is the universe made of? How did it begin? Are we alone in its vast expanse? Such questions inspire awe, curiosity, and a sense of unity, reminding us of the shared human desire to understand our place in the cosmos. Still, with every experiment, the debate over safety and ethics persists. Critics argue that even a minuscule risk of catastrophic events, however unlikely, warrants extreme caution. Proponents counter that the benefits of such research far outweigh the risks, pointing to the rigorous safeguards in place and the invaluable knowledge gained from past experiments. Ultimately, the story of the LHC is a microcosm of humanity's broader journey, a relentless drive to push boundaries, confront the unknown, and seek answers to the deepest questions of existence. It is a story of ambition tempered by responsibility, of exploration fueled by curiosity, and of progress achieved through collaboration. As the LHC continues its work, it serves as a reminder of both the power and fragility of human endeavor. It challenges us to imagine what lies beyond our current understanding and to approach the future with a mix of courage, humility, and respect for the forces we seek to comprehend. And so, the Large Hadron Collider hums on, its massive superconducting magnets guiding particles to unimaginable speeds, its detectors capturing glimpses of the fundamental building blocks of reality. Each experiment, each collision, brings us closer to answering age-old questions while simultaneously posing new ones. In this dance of discovery, the LHC remains a beacon of human ingenuity, a symbol of our insatiable quest to know and to understand, a quest as infinite as the universe itself.